Hi everyone, this video is part of Macquarie University's coding tutorials, and today we'll be taking a look at how to use ArrayLists as parameters for methods. We'll be discussing 4 different types of methods: accumulation, violation, validation, and handshake. You may also see these types of algorithms applied to arrays, but as we practice in this video of ArrayLists, you'll see how they work. This will also be great practice in using the built-in ArrayList methods. First, we have accumulation methods. An accumulation method is a method that iterates through and accumulates or combines all of the elements in the list into one value. An example of this is a method that takes in a list of integers and returns a sum of all integers. This works by looping over every integer in the list and adding it onto a sum or total variable which gets returned at the end. Next, we have violation and validation algorithms. Before we launch into an example of each one, it's useful to preface that they both arise when we need to determine whether something is true or false. The question we have to ask ourselves on writing one of these algorithms is, when can we stop? We can do this by imagining the method as a task we have to do manually ourselves first. For example, let's take a look at a violation algorithm. The example we use is a method that determines whether all the items in a list are even. Let's imagine we had physical boxes in front of us, and in each box there's a piece of paper with a single number written on it. To know whether every single box had an even number inside, we would have to check every single box. Just because we can open one box and find it has an even number, we can't say that all boxes have even numbers. In the same way, we can't check half the boxes and know all the numbers are even. The only way we could prevent ourselves from checking all the boxes is if we find an odd number. That is, something that violates what we're checking for. If we end up checking all the boxes and find that none of them are odd, only then could we confirm that all the boxes have even numbers inside of them. So in our code, if we find a violation to what we're looking for, that is, an odd number, false is returned. Since we found an odd number, we do not need to check the rest of the list, as we can only return true if after checking every item we did not find any odd numbers. Here, for each element, the method checks if the element is an even number by using the modulus operator to check if the remainder of the element divided by 2 is not 0. If this is true, meaning if the number is odd, the method returns false. If the loop completes without finding an odd element, the method returns true, indicating that all elements are even. A validation algorithm is the opposite sort of scenario. Here we would be satisfied if just one item fulfilled the criteria. This also means, however, that if we haven't yet found a matching element, we can't give up on looking for the box prematurely, meaning that we could potentially end up checking all the boxes, and only then could we say that we truly couldn't find a match and return false. In this code example, we have a method that checks if any element in a list is a duplicate, or in other words, occurs more than once. As soon as we find a duplicate value, we can return true. This method uses nested for loops to iterate through the list. The outer loop starts at the first element and goes through all the items. For each item, the inner loop goes through all the items again. This line of code checks if I and j are the same index, and if so, skips checking the item against itself. For example, we wouldn't grab a box, look away, then look at the same box again and say we found a duplicate. So we need this line to make sure we're not checking an item against itself. Then, for each pair of elements, the method checks if the elements are the same. If they are, the method returns true as there are duplicate elements in the list. This is the same as us physically grabbing 2 boxes at a time and checking if the numbers within the boxes are the same until we've checked all possible pairs. If we do find a pair that have the same numbers, we can stop immediately and say yes, there is a duplicate, which is the equivalent of returning true. If we get to the end of checking every pair and haven't found a matching pair, then we return false as there are no duplicate numbers in the list. One thing to note is that we've used the integer equals method to compare integers instead of the double equals operator. This has to do with the fact that integer is a class, meaning that with the double equals operator we would be comparing references. You'll find this does work for small numbers, however this is the result of an optimization with Java and not behavior that can be relied upon. Now looking at this method, we also uncover that we've had to use a handshake algorithm here. That is, for each item we had to compare it to every other item, which is why we have used a nested for loop. We use the term handshake as this is much like how at a gathering everyone will shake hands with everyone else. As an extra exercise, have a think about how you can reduce the number of pairs you need to check in the hasDuplicate methods. A hint is to think about how j is set in the nested loop. It's good to remember these types of algorithms and get into the habit of asking ourselves if a question fits any of these definitions. For example, if we've been given a problem, we need to identify if we can just go through the array or list with one for loop, or if for every item we need to check it against every other item. This is definitely a tricky skill to master and will come with practice. A great website to practice is CodingBat, which is free and gives you immediate feedback when you run a method just like JUnit. At this point, it would be useful to mention enhanced for loops, also known as for each loops. They provide an easy way to iterate through the elements of an array list without having to use an index variable. They don't only work on array lists, as we can also use them to iterate through most Java collections. However, understanding that aspect is beyond the scope of this course, and we'll just look at them in the context of array lists. The basic syntax is as follows. The data type is whatever the data type of the objects in the list are. If it's a list of strings, the data type is string. The variable can then be any name we want to use to refer to each object within the loop. Separated by a colon, ArrayList represents the name of the list we want to loop through. Then, inside, we write the code we want to execute, using the variable name as the reference for each item. For example, if we have an array list of integers called numbers, we can use an enhanced for loop to print out each element of the list. Notice this goes through each number and outputs it to the console. Enhanced for loops are great for when we are not interested in what index we are up to in the array or list, and instead just want to check every element from the beginning to the end. It's worth noting that enhanced for loops are read-only, which means we can't use them to modify the elements of an array list. If we need to modify the elements, we should use a regular for loop. Another thing to note is that we do not have to use the index and the .get method to access an element. Instead, the enhanced for loop allows us to directly access the elements of the array list. Here is another example of strings. The loop iterates through the elements of my list, assigning each element to the variable fruit in each iteration. Again, we can see the enhanced for loop eliminates the need to use the .get method to access the elements. Since we don't have to worry about incrementing an index variable and using the .get method, the code becomes more concise and easier to understand. Additionally, it also reduces the chance of running into an array index out of bounds exception, which can occur when using regular for loops and incrementing the index variable manually. I would recommend that you try to re-implement the algorithms we talked about in this video using enhanced for loops for extra practice. Remember to only use enhanced for loops when you don't need an index variable and when you're only accessing the items and not modifying the list. In this video, we have seen some examples of how to use ArrayList parameters in methods. We have looked at accumulation, validation, violation, and handshake algorithms. We also learned about how we can use the enhanced for loop when we need to retrieve the items of an array list in order, and that we should stick to using a normal for loop if we need to modify the list. In the next video, we'll go through how ArrayList should look in memory diagrams. See you there!